King Angelo E. Combustion Prelims number 1. Question. The compression ratio of an air standard Otto cycle is 9.5. Prior to the isentropic compression process, the air is at 100 kilopascal, 35 Celsius, and 600 cubic centimeter. The temperature at the end of the isentropic expansion process is 800 Kelvin. Using specific heat values at room temperature, determine A. Values: highest temperature and pressure in the cycle. B. The amount of transferred in kilojoule. C. The thermal efficiency. And D. The mean effective pressure. So, Otto cycle number 1. Otto cycle. So first is we should draw the diagram for Otto cycle, PV diagram. Two, 3, 4, and givens. Compression ratio is given. It's 9.5. P1 is given 100 kilopascal. T1 is also given 35 Celsius. Convert into Kelvin equals 35 308 Kelvin. Also, initial volume is given 600 cubic. Convert it into meter cube, cubic centimeter, 600. Okay, 0.0006 meter cube. Also, T4 is given 800 Kelvin. So in A, the highest temperature and pressure in the cycle. So here, P3 and T2. P3 and T3. First, in process 1 and 2, one to 2 is isentropic compression, where T2 equals T1, V1 over V2 is K minus 1. But first, since stated that the properties of air at room temperature, Cp is 1.005 kilojoule per kilogram K, and Cv is 0.718 kilojoule per kilogram K. R equals to 0.287 kilojoule per kilogram Kelvin, and K is 1, proportionality constant is 1.4. Now back to the problem. T1 is 308 Kelvin, and since compression ratio equals to V1 over V2, given compression ratio is given, you will use the compression ratio 9.5 times 1.4 minus 1. T2 will be 757.9 Kelvin. Now, to get the value of T2, since we have P1, T1, and V1, then we got T2. We will use P2 V2 over T2 equals P1 V1 over T1. To get the P2, B1 T2 over B2 T1 times P1. Since here you have in here V1 over V2 compression ratio, then right here compression ratio, then we have T2 over T1. We got T2, then 9.5, which is the compression ratio, times 757.9 over Kelvin over T1 is 308 Kelvin times the pressure 1 is 100 kPa. Solving it will become 9.5 757.9 308 100 2337.6786 kPa. Now P2 P3 process 3 to 4, which is isentropic expansion. Formula for T3 is T4 over V4 over T4 times V4 over V3 raised to K minus 1. We have T4. This is given 800 Kelvin. V4 and V3 also compression ratio now 9.5 times 1.4 minus 1 equals 800 1968.6995 Kelvin T3. Now we got the T3, which is the highest temperature. Now next is process 2 to 3 to get the highest pressure. In 2 to 3, V is constant heat addition, volume is constant heat addition. Now T3 over times B3 times T3 equals P2 V2 over T2. To get the P3 equals to T3 over T2 P2 equals 968.6995 over T2 is 757.9. P2 is 2337.6786 kPa. P3 is 7, 8, 6, 60. Let's check if R given 690 is 6,072.2874 kPa. Round that it is the highest pressure. Now let's go to B. B is amount of heat transferred. For B, first we need to find the mass. Mass is P1 V1 over RT1. Ideal gas law. 100 kPa. V1 is 0.006 meter cube. Times R is 0.287 times T1 is 308. Now mass is 6.788 times 10 raised to negative 4 kilogram. Now, to solve for heat, mCv T3 minus T2, since it is heat added, put the givens, 6.788 times 10 raised to negative 4, CV is 0.718, T3 is 1968.6995 minus T2 is 757.9 Kelvin. Solving for QA, 6.7 0.718 1968.6995 minus 757.9 is 0.590 kilojoule. Now that is QA. Then we also get QR in process 4:1. Since we got QA, now to let C is we should find the efficiency. So to find the efficiency, we need Q, heat rejected in process 4:1, which is isentropic. I mean constant heat rejected. Volume, constant heat rejected. QR equals mCv T3 T4 minus T1 minus equals negative 6.788 times 10 raised to negative 4. CV is 0.718. T4 is 800 Kelvin minus 308 Kelvin. QR equals to 0.240 kilojoule. Then in efficiency, work net over QA, but work net is also QA minus QR over QA. equals 0.590 minus 0.240 over QA 0.590. Efficiency is 59.4%. Now for mean effective pressure, V minimum equals V2 equals volume maximum over R. So formula for pressure equals work net over V1 minus V2. Since we got here 0.350 kilojoule, work net 0.350 kilojoule. But in here, V1 or V minus V2 also equals to V1 1 minus 1 over RK. Now solving for this, 0.350 over V1 is 0.006 cubic meter. 1 minus 1 over 9.5. Pmap is equal to 652 kPa. There. Thank you.